Welcome to Late Night History. Settle in. There is no hurry tonight, no need to follow every thread, no test at the end of any of this. You can let your eyes close whenever they want to. The story will keep going in the dark, the way a tide keeps moving, whether or not anyone is awake to watch it. Tonight, we are going to fall. Slowly, gently, and entirely in the imagination, we are going to drop a single tunnel straight down through the floor beneath you, through everything underneath this room, through the whole thick body of the planet, and out the far side into a sky on the opposite face of the world. And we are going to fall through it together and find out very calmly exactly what happens to a body that does that. Let me give you the strange little fact first. The one that has been quietly sitting in physics textbooks for a very long time, the one that almost everyone half remembers and almost no one truly understands. If you could bore a perfectly straight, perfectly smooth tunnel from where you are right now, clear through the center of the Earth and out the other side, and if you could empty that tunnel of all its air, so there was nothing to slow you down, no wind, no friction, nothing at all, and then, if you simply stepped over the edge and let go, you would arrive on the far side of the planet in about 42 minutes. 42 minutes, 12 seconds, if you want the precise figure that the mathematics hands back. Less time than it takes to watch a single television episode. Less time, perhaps, than it will take you to fall asleep tonight. You would drop down through the entire diameter of the Earth, a journey of nearly 13,000 kilometers, and you would step out the far end in about the time it takes to make and drink a slow cup of tea. That is the headline, and it is genuinely true, and it is the part everyone has heard. But here is the thing about that number, the thing that almost nobody gets right, the thing we are going to take the whole long night to unfold. It is so much stranger and so much gentler than the headline ever lets on. Because the 42 minutes is only the doorway. Behind it is a whole quiet cathedral of consequences, each one more peaceful and more astonishing than the last, and we are going to walk through every room of it without rushing a single step. Before we go any further down, though, let me ask you something, the way I always do. Wherever you are tonight, whatever corner of the world has gone dark around you, I would genuinely like to know. Leave it in a comment if you feel like it. The name of the place where you are letting this play. A city, a country, a quiet road somewhere. There is something I find very calming about all these distant rooms scattered across the planet, all these people lying still in the dark on every continent, and the thought that the very same tunnel, dug from any one of them, would take the very same 42 minutes. We will come back to why that is, because it is one of the most beautiful parts of this whole story, and almost no one tells it properly. And if you are new here, and you would like more of these slow journeys to drift off inside, you can subscribe very quietly, and the next one will simply be waiting for you whenever you want it. That is all. No more interruptions now. From here on, it is just the fall. So, let us actually build the tunnel in the only place it can ever truly exist, which is here, in the calm space behind your eyes. Picture the Earth not as the map you grew up with, all the painted countries and the borders, but as what it really is. A ball. An almost perfect sphere of rock and metal hanging in the black, turning very slowly, about 6,371 kilometers from its skin to its very heart. That number is worth holding for a moment because everything tonight grows out of it. 6,371 kilometers. That is the radius, the distance from the surface where you are down to the dead center, the single still point at the middle of the world. And if you go that far down and then keep going the same distance again, out the other side, you reach the far surface. So the full tunnel, all the way through from one face of the planet to the exact opposite face, would be a little over 12,700 kilometers long, 12,742 near enough. A shaft straight through the middle of everything. It is hard to feel a number that large, so let it settle slowly. If you could drive a car straight down that tunnel at a steady 100 kilometers an hour, never stopping, it would take you about 5.5 days of continuous driving to reach the far side. 5 days and 5 nights of nothing but tunnel wall sliding past. And yet, in free fall, with nothing to hold you back, gravity does the whole thing in 42 minutes. That is the first gentle shock of the evening. The same distance that would take a car the better part of a week, your falling body crosses in less than the length of a quiet afternoon nap. Hold that gap in your mind, the 5 days against the 42 minutes, because it is your first real hint that something very unusual is going on down there in the dark. Something is pushing you, and it is patient, and it never lets up, and it grows. Now the tunnel itself, we need it perfectly straight, like a beam of light frozen into the rock. We need its walls perfectly smooth so you never brush against them. And most importantly of all, we need it empty, empty of air, empty of everything. A vacuum, the kind of nothing you find out in deep space, threaded straight down through the heart of the planet. That emptiness matters enormously, and we are going to come back to it, because the difference between a tunnel with air in it and a tunnel without air in it is the difference between falling forever and finally coming to rest. But for now, tonight, in this first imagining, we keep it perfectly empty. No air, no wind, no resistance of any kind, just you and the open shaft and the long, dark drop. So you stand at the lip of it. Picture the edge, the rim of the hole, right at the surface where you are now. You can feel the ordinary weight of yourself standing there, the everyday pull that holds your feet to the floor, the same pull that is holding your body into the bed or the chair right now as you listen. That pull has a name, of course. We call it gravity, and we are so used to it that we almost never feel it as a force at all. It is just the way the world is. Down is down. Things fall. A dropped cup goes to the floor and never to the ceiling. We learn it before we learn to speak, and then we forget we ever learned it. But tonight, we are going to feel it again, freshly, as the strange and powerful thing it really is. Because the moment you step over that edge and let go, that quiet, familiar pull becomes the engine of the whole journey. There is no rope, no rocket, no machine. Gravity alone carries you the entire way. It does all the work, all 12,700 kilometers of it, and it never asks for a thing in return. You simply fall. And at first, the falling feels exactly like falling. The way it would feel to step off any high place, that lurch, that sudden lightness in the stomach as the floor drops away. You begin slowly, because falling always begins slowly, and then you gather speed. The walls of the tunnel start to slide upward past you, faster and faster, the surface light above shrinking to a small pale coin, then a pinprick, then gone, swallowed by the dark. And now there is only the dark, and the rushing, and the gathering speed, and the strange piece of a body that has surrendered completely to the pull of an entire planet. Here is where I want to slow right down, because here is where the real story begins. And it is not the story most people think it is. Most people, when they imagine this fall, imagine that gravity pulls harder and harder the deeper you go. It feels obvious, doesn't it? You are getting closer and closer to the center of all that mass, closer to the heart of the thing that is pulling you, so surely the pull gets fiercer the further down you go. Surely you are accelerating into a tighter and tighter grip, faster and more violent with every kilometer, until the center seizes you completely. But that is not what happens. That is exactly, precisely, the opposite of what happens. And the truth is so much gentler and so much stranger that physicists worked it out and then spent centuries being quietly delighted by it. Gravity does not get stronger as you fall toward the center of the Earth. Gravity gets weaker. The deeper you go, the less the planet pulls on you. And right at the very center, at the single still point in the middle of everything, the pull drops all the way to nothing at all. You become weightless, floating in the dead heart of the world, with the entire mass of the planet wrapped all the way around you in every direction, and not 1 gram of it pulling you anywhere. I know how strange that sounds, lying there in the dark, weightless, at the center of the Earth, with the whole planet surrounding you. It sounds like it can't be right, but it is one of the most beautiful and most settled results in all of physics, and the man who first truly understood why was the very same man whose name sits at the foundation of nearly everything we know about how things fall. We will get to him properly in a little while, to Isaac Newton, and to the elegant idea he gave us that explains the whole thing. For now, just hold the picture. The pull fading as you fall, fading, not growing, and the weightless stillness waiting at the center. Now keep that picture and add this to it, because the two of them together are the heart of the wonder. Even as the pull fades, even as gravity is gently loosening its grip on you the deeper you go, you are still speeding up the whole way down. All the way to the center, you go faster and faster. Slower acceleration, yes, gentler and gentler the deeper you fall, but still always forward, still always gaining. And so the very moment you reach the center of the Earth, the moment gravity finally lets go of you entirely and you become perfectly weightless, is the exact same moment you are moving at your absolute fastest. At the very center, you are weightless and you are flying. The two extremes meet in a single instant, in a single still point, in the dark middle of the world. The lightest you will ever be and the fastest you will ever go, both arriving at once. And how fast is that? How fast are you moving when you tear through the heart of the planet? About 7.9 kilometers every second. Let that one land slowly, because it is hard to hold. Nearly 8 kilometers in a single second, 28,000 kilometers in an hour, faster than any rocket human beings have ever built, faster than the fastest spacecraft, faster than anything that has ever left the ground. You, an ordinary body, having done nothing but step over an edge and let go, having burned no fuel and pressed no button, would be screaming through the center of the Earth at 28,000 kilometers an hour, carried there entirely by the quiet, patient pull that is holding you gently to your bed right now. And here is the gentle correction that almost no one gets right, the one that turns this from a story about falling into a story about something far stranger. You do not stop at the center. People always think you stop at the center. They picture being pulled down to the middle, the way a marble rolls to the bottom of a bowl, and coming to rest there, trapped forever at the heart of the world. But you are going far too fast for that. You arrive at the center at 28,000 kilometers an hour, weightless, and there is nothing there to stop you. So you simply keep going. You shoot straight through the dead center, through the still point, and out the other side. And now everything reverses. Now you are climbing. Now the far half of the planet is above you instead of below, and its pull begins very gently to slow you down. You rise through the second half of the tunnel exactly the way you fell through the first, only mirrored. Slowing the pull, strengthening again as you climb back out toward the far surface, 28,000 kilometers an hour, bleeding away kilometer by kilometer, until, at the very moment you reach the opening on the far side of the world, your speed drops all the way to zero. You arrive. You come to a perfect, gentle stop, your head just rising above the rim of the far tunnel into a sky you have never seen, on the opposite face of the planet, exactly 42 minutes after you let go. Having traveled nearly 13,000 kilometers through solid rock and the heart of the world, you would arrive as softly as a leaf settling on still water, with no speed left at all, right at the lip of the far side. And if you reached out and grabbed the edge at that perfect moment, you would have crossed the entire planet for free in less than the length of a lunch break. But if you didn't grab the edge, if you just let yourself hang there for that one weightless instant at the top of your rise, well, then the whole thing begins again, in reverse. We will come to that, to the endless, gentle rhythm of it, a little later tonight, because it is one of the most soothing pictures in the whole of physics, and it deserves its own quiet stretch of the dark. For now, just know that the fall does not end. Not really, not without air. Now, I told you I would name the thing that runs underneath all of this, the deep pattern that makes the falling so clean and so predictable, and here it is. What your body is doing in that tunnel has a name. Physicists call it simple harmonic motion. It is a slightly cold-sounding phrase for one of the warmest and most familiar patterns in all of nature. So let me hand it to you in a way you can actually feel, because once you feel it, the whole 42 minutes makes a kind of sense in your bones. Think of a child on a swing. You pull the swing back and let go, and it falls forward, gathering speed, fastest at the very bottom of its arc, then rising up the far side, slowing, until for one tiny, weightless instant, it hangs at the top, perfectly still before it falls back down again, down through the bottom, fastest at the middle, up the other side, pause and back. Over and over in a steady, unhurried rhythm, the same time for every swing, whether it is a big arc or a small one. That is simple harmonic motion. The swing is doing it. A pendulum in an old clock ticking back and forth in the corner of a quiet room is doing it. A weight bouncing slowly on the end of a soft spring, settling up and down, is doing it. And your body, falling through the earth, is doing exactly the same thing. It is the very same pattern, the very same mathematics, just written across the entire body of a planet instead of across a swing in a garden. You fall fastest at the center, the way the swing moves fastest at the bottom. You slow as you rise toward the far side, the way the swing slows as it climbs. You pause, weightless at the far surface, the way the swing hangs for an instant at the top of its arc, and then you fall back. The whole journey through the earth is one long, slow, gentle swing, and the center of the planet is simply the bottom of the arc. That is why it is so smooth. That is why it is so predictable. That is why it always takes the same time. It is the oldest, calmest rhythm in physics, the rocking rhythm of the swing and the pendulum and the spring, scaled up until it is large enough to hold the whole world. There is something deeply restful in that, I think. The idea that the violence of falling through 12,000 kilometers of rock at the speed of a rocket is, underneath, just the same gentle rocking as a cradle, the same back and forth that soothes a child to sleep. The planet itself, treated as a single great pendulum, swinging one small body slowly through its heart and out the other side, in the same unhurried rhythm as a porch swing on a summer evening. Nature reaches for the same few patterns over and over, the simplest ones, the most economical ones, and this rocking, swinging rhythm is one of its favorites. It shows up in the smallest things and the largest, in a single atom, trembling, and in a body, falling through a world. Now you might be wondering who first thought of any of this, who first looked at the solid earth under their feet and wondered seriously, what would happen if you could simply drop straight through it? And the answer takes us back a very long way, into the 17th century, into the age of candlelight and quill pens, and the very first true science of how the world moves. It takes us, in fact, to a single letter written more than 300 years ago between two of the greatest and most quarrelsome minds England ever produced. The year was 1692, and a man named Robert Hooke, a brilliant, restless, endlessly curious figure, sat down to write to Isaac Newton. Hooke was the kind of mind that could not leave a question alone. He thought about springs, about light, about the cells in a sliver of cork seen under one of the first microscopes, about the way the planets held to their courses. And somewhere in his thinking, he turned over this very question. What would happen, he wondered, to an object dropped into a hole that ran straight through the earth? Would it fall to the center and stop? Would it pass through? What path would it take? He put the question to Newton in correspondence, the two of them passing these deep puzzles back and forth across the distance like men playing a slow game of chess by letter. And the reason that letter matters so much, the reason we still remember it tonight, lying here in the dark 3 centuries later, is that Newton was the one person in the world who held the key to answering it properly. Just a few years earlier, in 1687, Newton had published the book that would change everything. Its full name is long and Latin, but it is known to history simply as the Principia Mathematica. In it, Newton laid down the laws of motion and the law of gravity that between them describe how nearly everything moves, from an apple falling from a branch to the moon swinging around the earth to, yes, a body falling straight through the heart of a planet. Inside that one book was everything you need to work out the 42 minutes. The mathematics that would one day give us that precise, gentle number was already there, written down, waiting 330 years ago by candlelight. So when we lie here tonight and imagine the fall, we are not imagining something new. We are walking back into a question that was already old when our great-great-grandparents were not yet born. A question that two extraordinary minds turned over in letters by candlelight in a London of horse-drawn carts and coal smoke, long before anyone had ever flown, long before anyone had ever seen the earth whole from space, long before any of the great instruments we have now. They could not dig the tunnel, they could not test it, they would never see the answer made real, but they could think it through, carefully, patiently, with nothing but the laws Newton had written and the quiet machinery of the mind. And the answer they could reach on paper by reason alone is the very same answer we have tonight. 42 minutes, carried entirely by gravity, following the gentle rocking rhythm of a pendulum scaled up to the size of a world. There is a particular kind of peace in that, I find. The thought that this exact journey we are taking tonight, this fall through the dark heart of the planet, was first taken in imagination by men who have been gone for centuries, that the path was traced quietly in ink long before any of us were here, and will go on being traced quietly long after. The tunnel does not exist, it never has. It almost certainly never will, for reasons we will come to, reasons of fire and pressure and a hidden ocean of molten metal that we have not even begun to speak of yet. And yet, the fall is real. The 42 minutes is real. The weightless center and the rocket speed and the gentle pause at the far side are all as real and as certain as anything in the world, real in the only place they can ever happen, which is in the careful, patient, candlelit imagination handed down from Hooke to Newton to the textbooks to this quiet room, tonight to you. So let us hold there for a moment at the very beginning of the fall, before we go deeper. We have stepped over the edge. We have felt the surface light shrink to nothing above us. We have begun the long drop through 12,700 kilometers of darkness, with gravity for our only engine, fading gently as we go, carrying us faster and faster toward a center where we will be weightless and flying both at once. We have learned that we do not stop there, that we shoot straight through and rise out the far side in exactly 42 minutes, as softly as a settling leaf. And we have learned that all of it, the whole vast plunge, is nothing more than the oldest gentle rhythm in nature, the rocking of a swing, the swing of a pendulum, the slow rise and fall of a weight on a spring, written across the body of an entire world. But we have not yet asked the deepest question of all. We have not yet asked why. Why does gravity fade as you fall toward all that mass when every instinct says it should grow? Why does the pull vanish completely at the center when the whole planet is wrapped around you? The answer is one of the most elegant ideas Newton ever gave us, a beautiful piece of reasoning that explains everything we have just felt, and we are going to take it slowly, very slowly, in the next stretch of the dark. So stay with me if you are still here, drifting along the smooth wall of the tunnel. Let yourself keep falling. The center is still a long way down, and there is so much more to understand about the gentle, impossible journey we have only just begun. The answer begins with a shell. Not a shell you can hold, not a shell from a beach or a garden wall, but a mathematical shell, a thin, hollow sphere of rock and iron, drawn as a concept in the mind, real in its consequences. And the reasoning that follows from it is so clean, so inevitable, that once you have seen it, you cannot quite believe it was ever hidden from you. Imagine, as you continue to fall, that the earth around you is not a solid ball at all, but instead a set of hollow spheres nested one inside another like the layers of an onion. Each layer is a shell, the crust is a shell, the upper mantle is a shell, the lower mantle is a shell, the outer core is a shell, the inner core, deepest of all, sits at the very center. And as you fall, you pass through these shells one by one, leaving each of them behind above you until finally, at the very bottom of the journey, you are surrounded by them all, with nothing beneath you in any direction. Now here is the question Newton asked and answered in the Principia Mathematica in 1687. What is the gravitational effect of a hollow spherical shell on a body inside it? Not outside, not on the surface, inside. You are somewhere in the middle of a hollow sphere of rock. Every part of that sphere is pulling on you gravitationally. The part directly above you pulls you upward. The part directly below you pulls you downward. The parts to your left and right pull sideways. The pulls come from everywhere at once, from every point on that vast, curved surface surrounding you. What is their combined effect? Newton proved something that feels, at first encounter, almost too clean to be true. A uniform spherical shell exerts no net gravitational force on any object located anywhere inside it. Not a tiny force, not a negligible force, exactly no force. Zero by precise cancellation. The reason is geometry, and it is worth holding in your mind gently as you fall. If you are inside a hollow sphere, the portions of the shell directly above and below you are different in size. The portion just above you, in whatever direction you choose to call up, is relatively small and nearby. The portion of the shell on the opposite side, below you, is larger and farther away. It turns out that for any spherical shell, these two quantities, the area of rock pulling in one direction and the distance to that rock, are always perfectly balanced against each other. The larger, farther mass pulls you with exactly the same force as the smaller, nearer mass. Every tiny patch of the shell has its precisely calibrated counterpart somewhere else on the sphere, pulling in exactly the opposite direction with exactly the same strength. And when you sum up all these opposing pulls across the entire shell, they cancel completely. This is the shell theorem. It is not an approximation. It is not true only under special circumstances. It is exact for any spherically symmetric shell, for any position inside it, for any gravitational force governed by Newton's inverse square law. The shell, in its entirety, does nothing to you. It is as though it is not there. And this is the key that unlocks the strange behavior of gravity inside the Earth as you fall. Because here is what the shell theorem means for your journey. When you were standing on the surface, the full mass of the Earth was below you, pulling you down. The whole planet, all 6 times 10 to the 24th kilograms of it, was contributing to the gravity that held you to the ground. But the moment you stepped into the tunnel and began to fall, the situation changed. As you descend past the first kilometer, the outermost shell of rock, that thin skin of crust above you, stops contributing to the pull. It is now a shell surrounding your current position. It exerts no net force on you. Only the mass still below you. Only the sphere of Earth, smaller than your current depth, counts. As you fall further, more and more shells of rock and iron pass above you, each one ceasing to contribute, each one becoming part of a shell that cancels itself out completely. The effective mass pulling you down is not the whole Earth. It is a steadily shrinking ball, the ball with radius equal to your current distance from the center. And here is the consequence that undoes every instinct. As you go deeper, that inner ball gets smaller. A smaller ball means less mass. Less mass means less gravitational pull. The deeper you fall inside the Earth, the weaker the gravity pulling you toward the center. Not stronger. Weaker. Every person who has not thought carefully about this assumes the opposite. You are falling toward the densest, most massive concentration of matter on Earth. Surely gravity should be pulling at you harder and harder, pulling you apart, crushing the breath from your lungs. But the shell theorem takes the vast bulk of that mass out of the calculation entirely, piece by piece, as each shell rises above you, and what remains is always and only the smaller sphere still beneath your feet. Gravity decreases steadily, continuously, all the way down. For the simplified model we are using, and the one that assumes the Earth has the same density throughout, all the way from the crust to the core, this relationship is beautifully linear. The gravitational acceleration you feel is directly proportional to your distance from the center. Twice as far from the center means twice as much gravity. Half as far means half as much. 3/4 of the way to the center means you feel only 3/4 of the surface gravity. 1/4 of the way in, only 1/4. And at the very center itself. At the exact midpoint of the Earth, 12,742 kilometers below where you started. 0. Let that settle for a moment. At the dead center of the Earth, the gravitational acceleration is 0. You weigh nothing. Not because gravity has somehow run out, not because you have escaped into space, but because the shell theorem is operating with full, terrifying symmetry. At the exact center, every single atom in the Earth is somewhere in the shell surrounding you. Every piece of mass is, by the shell theorem, perfectly cancelled by the mass on the opposite side. There is no net force in any direction. The Earth pulls at you from every point simultaneously, and every pull is exactly undone by its counterpart. You float, you are weightless, at the center of a world, surrounded by iron and rock at thousands of degrees in every direction, wrapped in the full mass of the planet, pressing inward from all sides, and in the gravitational sense, you are as free from weight as an astronaut drifting in deep space. There is a stillness in that idea, a very particular kind of stillness, the stillness of something so perfectly balanced that all forces simply vanish, not cancelled by a mechanism that takes effort, cancelled by the geometry of the sphere, which has been doing this silently, automatically for every object inside every spherical body in the universe, since long before Newton gave it a name. This is the mathematical heart of why the fall behaves the way it does, and it leads directly to one of the most precise, most satisfying equations in all of classical mechanics. Because when you say the gravitational force acting on you is proportional to your distance from the center, and that force is always directed toward the center, you have described something a physicist recognizes immediately. You have described a restoring force, a force that always points back toward the equilibrium position, always proportional to how far you are from it. Pull a mass on a spring to one side, and the spring pulls it back toward the middle with a force proportional to how far you have pulled it. The mass oscillates. This is simple harmonic motion. Your fall through the earth is exactly simple harmonic motion, exactly the same mathematics. The center of the earth is the equilibrium point. Gravity, depleted by the shell theorem as you approach it, is the restoring force. And the motion that results is a perfect sinusoidal oscillation, smooth and continuous, mathematically identical to the rise and fall of a pendulum at small angles, or the vibration of a tuning fork, or the expansion and contraction of a weight bouncing on a rubber band. The equations that govern your fall are the same equations a student encounters in a first-year physics course when studying springs. You use Newton's laws, you write down that the force is proportional to the displacement, and you arrive at a differential equation with a well-known solution. The object moves as a cosine function of time, oscillating at a fixed frequency that depends only on the strength of the restoring force, not on how far you initially displaced the system, not on how big the tunnel is, not on what direction you dug it. For the Earth, the restoring constant comes from Newton's gravitational constant and the Earth's mass and radius. You put in those numbers, you solve for the period, and you get 84.4 minutes for a complete round trip, down through the center, out the far side, all the way to the surface, and then back again. One full oscillation, 84.4 minutes. Which means the one-way journey to down through the center and out the other side is exactly half of that. 42.2 minutes, often rounded in papers and textbooks and late-night physics discussions, simply to 42 minutes. There is the number, not handed down from authority, not pulled from a simulation, but derived step by step from the shell theorem and Newton's laws, as cleanly as you would derive the period of a pendulum. The Earth's geometry, its mass, its radius, the constant of gravitation. All of them feed into the calculation, and what comes out, with the inevitability of mathematics, is 42 minutes. Now, the question you are probably holding somewhere at the back of your mind, the one that wants to resolve itself before you drift further into the dark, is this. If the gravitational pull is getting weaker and weaker as you approach the center, how is it possible that you are still accelerating? How do you get faster if the force pulling you is fading? The answer is that the force does not need to stay strong to keep accelerating you. It only needs to stay positive. Any net force, however small, will change your velocity. And for the entire first half of the journey, all the way from the surface to the exact center, gravity is pulling you forward toward the center, however weakly. Even at 99% of the way down, with barely 1% of surface gravity remaining, that tiny pull is still adding to your speed. You are still accelerating. Every second of that long descent, you gain a little more velocity, even as the force responsible grows fainter. And so, despite the weakening pull, your speed rises throughout the entire downward half of the journey, continuously without pause, reaching its maximum at the very moment gravity reaches its minimum. At the center, where gravity is exactly zero, you are moving faster than you have moved at any other point in the journey. The numbers here are worth holding still for a moment. In the uniform density model, the maximum speed you reach at the midpoint is approximately 7.9 kilometers per second. That is the speed of a rifle bullet multiplied by many times over. It is roughly equal to 28,000 kilometers per hour, or just over 17,600 miles per hour. At that speed, you could travel from London to New York in something under 13 minutes. You could travel from the Earth's surface to the Moon in something under 15 hours without any additional thrust. The space station, in low Earth orbit, circles the planet at a speed that is close to this value. You, at the center of the Earth in a frictionless tunnel, would be moving at approximately orbital velocity, and gravity is zero. You are weightless, at the dead center of a world, screaming through the dark at nearly 8 kilometers per second, with nothing pulling on you in any direction. That specific moment, maximum speed, zero gravity, total weightlessness, absolute darkness and heat and pressure in every direction, is perhaps the most extreme and paradoxical condition this entire journey visits. The universe's most peaceful-sounding physical state, floating in zero gravity, achieved deep inside the most hostile environment you could conceive of placing yourself. Now, here is the correction the frictionless ideal demands that most people get wrong, and it is important enough to name clearly: you do not stop at the center. It is a reasonable thing to imagine. You have been falling a long time. The pull of gravity has softened to nothing. You are at the deepest point you can reach. Surely this is where you slow to a halt and hover, suspended at the middle of everything. No, you pass through the center at maximum speed. You are accelerating all the way to this point, and inertia, momentum, the unwillingness of a moving mass to change its velocity without a force, carries you straight through. The moment you cross the midpoint, the geometry reverses. The mass now above you, which was part of the shell while you were falling toward the center, is now partly below you again, in the sense that you have passed it. No, more precisely, the moment you go past the center and start rising toward the far side, the effective gravitational pull shifts. It now points back toward the center, back the way you came, because the shrinking sphere of mass below you is now pulling you backward. Gravity has become a restoring force in the other direction. You decelerate, smoothly, continuously, exactly mirroring the acceleration of the downward half. Your speed falls as you rise through the Earth on the far side, along the same curve, in reverse. The kinetic energy you accumulated on the way down is given back symmetrically as you climb. When you finally reach the surface on the far side, at the antipodal point, the far opening of the tunnel, you arrive with exactly the speed you had when you began, zero. You step out, or emerge, or arrive, in whatever manner you allow yourself to imagine, at exactly the same speed you had when you stepped in. Gravity has borrowed your kinetic energy to carry you through 12,700 kilometers of Earth, and it has given every joule of it back. And then, in the frictionless ideal, you stop, momentarily. For the briefest conceivable instant, your velocity is zero. You are balanced at the far rim of the tunnel with the entire planet beneath you. And then you begin to fall back, because nothing has changed. You are standing at the opening of a tunnel at the surface of the Earth, with gravity pulling you downward. The situation is identical to where you started, and so the fall begins again, in reverse, with the same forces, the same acceleration profile, the same quiet deceleration through the far half, and the same arrival at the far side, which is now the original opening, and with exactly zero velocity. You have made a round trip. You are back where you started. 84.4 minutes have passed. And then you fall again. Without friction, without air resistance, without any force dissipating your energy, you would do this forever. The oscillation would never decay. You would travel back and forth through the Earth in an eternal rhythm, 42 minutes down, 42 minutes back, perpetually exchanging potential energy for kinetic energy, and back again in a perfect conservation of mechanical energy that the laws of physics would insist on maintaining indefinitely. An eternal pendulum. not between 2 points in the air, but between 2 points on the surface of a world with 12,000 kilometers of rock and fire and iron in between. It is, if you let it, a strangely calming image, not the violence of a fall, but the patience of a pendulum, the same steady rhythm that rocks a swing in a garden, that ticks the seconds away in a grandfather clock, that carries the tides in and out along a shore, the same mathematics, the same endless exchange of energy, written here across the diameter of a planet, invisible, noiseless, impossibly serene. The period of a pendulum does not depend on the mass of the pendulum bob. A heavy weight and a light weight on the same length of string swing at exactly the same rate. This is Galileo's insight from the 16th century. The one legend says he discovered watching a chandelier sway in the cathedral at Pisa, though the story is probably embellished. Regardless, it is true. And the same independence of mass holds for the gravity tunnel. A person, a coin, a planet-sized boulder, a single hydrogen atom. Released at the surface, they all arrive at the far side in 42 minutes. Their mass is irrelevant. The period depends only on the Earth's mass, the Earth's radius, and the gravitational constant. The traveler is along for the ride, and the ride takes the same time for everyone. But the period does not depend on something else either, something more surprising. And here we reach the result that most discussions of this problem never quite manage to illuminate clearly, the result that is, in some ways, the real heart of the gravity train thought experiment. The period does not depend on the length of the tunnel. Let us stay with that slowly. 42 minutes for the through-center tunnel from pole to pole or from one side of the equator to the other, 12,000 kilometers straight through the fire. That seems reasonable enough, perhaps even expected. It is the longest possible tunnel through the most Earth, and it takes 42 minutes. But what about a shorter tunnel? A tunnel that does not go through the center at all, but cuts a shorter chord through the Earth, missing the core entirely. A tunnel from New York to London, say, a chord that passes only through the upper mantle, never venturing near the outer core, never approaching the blazing inner regions. That tunnel would be thousands of kilometers shorter than the through-center one. You would be falling through less Earth. With less distance to cover and presumably a different gravitational profile along the way, would it not take a different amount of time? It would not, and the reason why takes us back to the shell theorem and to the geometry of circles and to the simplest, most satisfying kind of mathematical result, the kind where everything cancels. When you dig a tunnel along a shorter chord, one that misses the center, gravity does not pull you straight down the tunnel. It pulls you straight toward the center of the Earth, as it always does. But only the component of that pull, which lies along the tunnel's direction, actually moves you through the tunnel. The perpendicular component is absorbed by the tunnel walls, which push back on you and keep you on track. Now here is the beautiful part. As you move along the shorter chord, the distance from the center of the Earth changes, but so does the angle between the gravitational force and the tunnel direction. These two quantities, the magnitude of the gravitational force and the component of it aligned with the tunnel, combine in a way that turns out to be exactly proportional to your displacement from the midpoint of the chord, the same form, the same type of restoring force. Simple harmonic motion, again, with exactly the same period as before. The proportionality constant works out to be identical, regardless of which chord you have chosen, regardless of what angle the tunnel makes with the Earth's radius, regardless of whether you are traversing 1,000 kilometers or 12,000. Any straight tunnel through a uniform Earth takes exactly the same time to traverse, 42 minutes, one way, 84 minutes, and change for the round trip. Paul W. Cooper laid this out carefully in a 1966 paper in the American Journal of Physics titled Simply and Perfectly Through the Earth in 40 Minutes. The result had been glimpsed before in various forms by mathematicians working on related problems, but Cooper stated it clearly, showed the calculation, and gave the world a delightfully memorable phrase to carry away. And so the gravity train is not just a tunnel through the center, it is a network. Any 2 points on the Earth's surface connected by a straight tunnel would take exactly the same 42 minutes to traverse. The tunnel from Moscow to Buenos Aires, the tunnel from Sydney to Stockholm, the tunnel from a city on the coast of Spain to the nearest antipodal point in the South Pacific. All of them 42 minutes in the ideal frictionless model, each of them a different length at a different angle through the Earth, each one passing through a different set of geological layers, and every single one taking the same time. You could build a transit network connecting every major city on Earth with no fuel, no engines, no propulsion of any kind, and every journey between every pair of cities would arrive in exactly 42 minutes. Gravity would do all the work. Gravity, working through the geometry of the sphere and the elegant symmetry of the shell theorem, would carry every passenger on every route in the same time, effortlessly, perpetually, exchanging potential energy for kinetic energy and back again, with not a gram of fuel consumed, not a kilowatt-hour of electricity spent. It is the most extravagant fantasy in transport physics, and it is mathematically exact. In the waking world, of course, there is nothing free about it. The energy that gravity provides was deposited by whoever built the system, by the process of lifting people and freight to the surface from wherever they began. Gravity is not conjuring energy from nowhere. It is returning the potential energy that exists by virtue of being on the surface of a massive planet. But within the terms of the thought experiment, within the serene abstraction of frictionless tunnels and uniform density, the system is as close to perpetual free transit as physics ever permits. There is, in this image, something that belongs to a certain kind of dream. Not the anxious dream, not the dream of falling that wakes you, but the other kind, the long, slow, geometric dream where everything connects seamlessly, where distances dissolve, where the architecture of the world arranges itself into symmetry, and you travel through it without effort, arriving everywhere in the same unhurried 42 minutes. The gravity train, in its pure mathematical form, is that dream made rigorous. And the frictionless oscillation, the traveler who misses their stop, or who simply never intended to stop, who falls through and keeps going 42 minutes out, 42 minutes back, forever, is something else, a kind of cosmic patience, a movement so perfectly balanced it requires nothing to sustain itself, nothing to start itself over, a piece of the universe's preference for conserving energy that plays out here, in the dark and the heat, beneath 12,000 kilometers of stone. There is one more thread here worth pulling gently before we move on. One more unexpected connection, the kind that physicists notice and quietly delight in. The 84.4 minutes for a full round trip through the gravity tunnel. That number, hold it for a moment. Now think about a satellite, a real satellite, not in the high orbit of a communications platform or the medium orbit of GPS, but a satellite in the lowest possible orbit, one that grazes the very surface of the Earth, a hypothetical satellite that skims along at zero altitude, passing continuously over the surface at whatever speed is needed to maintain that orbit. How long does it take to complete one full circle around the Earth? Approximately 84 minutes. The period of a low Earth orbit, defined as the period of a circular orbit at the Earth's surface, is 84 minutes. The exact figure depends on how precisely you take the Earth's density and radius, but to the same level of approximation as the gravity tunnel calculation, the two numbers are the same. The gravity tunnel oscillation period and the surface skimming orbital period are identical. This is not a coincidence in the sense of being meaningless, though it is certainly a coincidence in the sense of being unexpected. Both the orbiting satellite and the falling tunnel traveler are governed by the same gravitational constant, the the same Earth mass, the same Earth radius. The satellite moves in a circle, balancing gravity against centripetal acceleration. The tunnel traveler moves in a straight line, oscillating under the Shell theorem-reduced gravity. The mathematics, approached from completely different directions, arrives at the same period. It is as though the Earth has one fundamental timescale for objects moving freely under its gravity near its surface, whether they are circling it above or oscillating through it below. The planet sets the clock, and the clock ticks at 84 minutes, regardless of the path. The satellite skimming the surface and the person falling through the tunnel are, in a deep mathematical sense, doing the same thing. They are both in free fall. The satellite is falling continuously but moving fast enough sideways that the Earth's curved surface falls away beneath it at exactly the rate the satellite is falling toward it. The tunnel traveler is falling along a straight line, constrained by the tunnel walls. One traces a circle, one traces a line. But the restoring mathematics, the relationship between the Earth's mass and the period of motion, is the same for both. There is a stillness to knowing this, to understanding that the satellite passing overhead in 84 minutes and the imagined traveler oscillating through the Earth in 84 minutes are two expressions of the same thing, that the sky and the deep interior, in this one precise sense, keep the same time, that the Earth has woven this particular number into the structure of free motion near its surface, and it shows up everywhere you look for it. You could, drifting in the dark of the tunnel, think of yourself as a kind of satellite, not circling above, but threading through. The orbit and the oscillation are one motion seen from different geometries. The 42 minutes is half of that, the one-way journey, the longest, most fundamental commute in the thought experiment of physics. And it comes from the Earth itself, from its mass and its radius, and its willingness to let you fall through it, from Newton's theorem about hollow spheres and the inverse square law of gravity, from a piece of mathematical reasoning worked out in a room in London in the 17th century, long before anyone knew how deep the Earth went or what it contained. The number is exact in the sense that the model gives it. It is 42 minutes and 12 seconds to be precise, usually rounded without ceremony to 42 minutes. And there is something about that particular number that catches, that lodges in the memory and refuses to let go. Not because of anything intrinsic to the physics, but because of a coincidence so absurd it has to be mentioned, even here, in the gentle dark of a sleep documentary, even knowing that it is nothing more than coincidence. 42 is famously the answer. Not an answer to the gravity tunnel, but the answer to life, the universe, and everything, as given by a vast and ancient supercomputer in Douglas Adams' novel The Hitchhiker's Guide to the Galaxy, published in 1979. The computer ran for 7.5 million years and produced the number 42, without ever revealing what the question was. The number has been a touchstone of science culture ever since, a shorthand for the feeling that the universe has answers and we may not have the right questions. And here, independently, the physics of a tunnel through the Earth hands you 42 minutes. Physicists notice this. They smile at it. They do not believe it means anything because it does not. The units are different. The context is entirely different. And Adams chose 42 for its deliberate banality, not for any resonance with geophysics, but the smile is real. The universe, or at least the part of it occupied by physics, textbooks, and science communication, has a fondness for this number. And if you are going to fall through the Earth for 42 minutes, it is at least pleasant to fall with a smile. The number is meaningless. The physics that produces it is not. And if you are still here, still drifting in the quiet dark of the tunnel, still following the slow descent through Shell theorem and restoring forces and the eternal pendulum, then you already understand something that most people who have heard the 42-minute figure have never quite grasped. Not just the what, but the why. You know why gravity fades as you fall. You know what is happening at the center. You know why you cannot stop there, and why the oscillation never ends without friction, and why any tunnel through this planet, however shallow, takes the same patient 42 minutes. You know that the number comes from the Earth itself, from its geometry and its mass, and that it shows up again in the sky in the period of the lowest satellite, because both are speaking the same gravitational language. And somewhere in the back of the mind, in the part that keeps the ongoing threads of a long journey organized, there is a question that has not yet been asked. All of this, the shell theorem, the maximum speed, the eternal oscillation, the any-chord theorem, the coincidence of orbital periods, all of this rests on an assumption. A simplifying assumption, stated quietly at the beginning and not yet revisited. We have been assuming the Earth is uniform, that it has the same density from the surface all the way to the core, that it is, in the gravitational sense, a perfect homogeneous ball. It is not. The Earth has a dense iron-nickel core, a massive, extraordinarily dense concentration of metal at its heart, surrounded by a mantle of different rock at different depths, wrapped in a thin crust of yet another composition. The real Earth does not have the same density throughout, and the real Earth's gravity does not simply decrease linearly as you fall toward the center. This means the gravity tunnel calculation we have just done, the one that produces 42 minutes, is technically wrong. Not by much, but not by nothing. And when you do the calculation properly, or with the real measured density profile of the actual Earth, the one worked out by seismologists and geophysicists over decades of listening to earthquake waves ripple through the planet's interior, you get a different number. What that number is, and what it means for the journey we have been imagining, and what the real Earth is actually like in those depths that produce the correction, those are the questions waiting in the next part of The Dark. And so we must return to that assumption, hold it up quietly in the dark, and look at what it has been hiding, the any-chord theorem. That is the name for something the mathematics has been quietly carrying all along, something that the previous reasoning built toward without quite stating yet, something that deserves its own slow turning over in the mind before we move on to the correction the real Earth demands. Here is what it says, and it says it with a stillness that the first time you truly understand it is almost unsettling. A tunnel bored from New York to Los Angeles, a shallow diagonal cut through the upper layers of the crust and mantle, never anywhere close to the center of the Earth, a chord that passes at most a few hundred kilometers below the surface, takes exactly as long to traverse as a tunnel bored straight through the planet's heart from one pole to the other. Exactly as long. To the second. The same 42 minutes one way that the through-center journey requires, the through-core fall, we have been tracing through the shell theorem and the silence at the midpoint and the maximum speed of 28,000 kilometers per hour. That same duration belongs equally to the shallow tunnel, the modest tunnel, the tunnel that barely dips below the continents and never approaches anything like the core. 42 minutes either way. This is not an approximation. It is not approximately the same or roughly comparable or within the same order of magnitude. Under the uniform density assumption, the through-center time and the any-chord time are precisely identical, and the mathematics that produces this result is the same mathematics we have already met. To understand why, you have to think about what happens to gravity inside a chord that does not pass through the center. Imagine the shallow tunnel between those two cities. You are sitting at one end, in the dark, at the entrance to a tunnel that slopes gently downward into the Earth, following a straight line that will eventually bring you up again on the other side of the continent, emerging into the afternoon on the far coast. The tunnel does not aim at the center of the Earth, it aims at Los Angeles. It is an oblique, diagonal cut, like a cord drawn across a circle somewhere well above the circle's midpoint. You let go, you fall. Now the gravitational force, acting on you at any point inside the Earth, is directed toward the center of the Earth, not along your tunnel. Gravity always pulls toward the center. It does not know which direction your tunnel runs. It is simply pulling you downward toward the deepest point of the planet, along a line that points through your body toward the core. But your tunnel runs at an angle to that force. You are not falling straight toward the center. You are falling along a slanted path. What matters then is not the full gravitational force. It is only the component of that force that points along your tunnel. The rest of the force is pushing you sideways, pressing you into the tunnel wall if it were a real tunnel, but having no effect on your motion along the tunnel's direction. And the component of gravity that is aligned with your path, the piece of the force that actually moves you along the cord, that is the only piece that matters for calculating your travel time. This is the key. And here is where the mathematics does something beautiful and unexpected. For the through-center tunnel, the gravitational force at any depth is directed exactly along the tunnel. They point the same way, and that force is proportional to the distance from the center. The deeper you go, the less mass is below you and the more is above, and the force is exactly proportional to how far from the center you are, which in this case is also how far from the midpoint of the tunnel you are, which means you have simple harmonic motion, the same equation as a spring, the same period regardless of how far you push the spring, the same 42-minute transit. For the off-center tunnel, the shallow cord, the gravitational force is not aligned with the tunnel, but its component along the tunnel is, and the component of gravity pointing along the tunnel direction at any position along that cord is proportional to the distance from the midpoint of the cord. Not the distance from the center of the Earth, the distance from the midpoint of the tunnel you are traveling through. The geometry conspires, and this is the part that takes a moment to absorb, to make the restoring force along any straight tunnel through a uniform Earth exactly proportional to displacement from that tunnel's own midpoint. The shape of the restoring force is always the same, the formula is always the same, the period is always the same, simple harmonic motion whatever chord you draw, the same 42 minutes. Paul W. Cooper was the physicist who brought this result into clear, accessible focus in the 20th century, in a 1966 paper published in the American Journal of Physics under the title Through the Earth in 40 Minutes. The result had ancestors, as almost all things in classical mechanics do. The mathematics of falling through holes in the Earth had been explored in various forms going back centuries, but Cooper's treatment was direct, clear, and aimed at making the extraordinary generality of the result visible, not just the through-center case, the polar tunnel or the diameter, the any-chord case, the everywhere case. The theorem that says that the transit time through a frictionless gravity tunnel between any 2 points on the surface of a uniform density Earth is the same. 40 minutes, he titled it, 42 minutes more precisely. But the rounding is beside the point. The point is the universality. Think about what this means held up very slowly in the dark. You could, in this imagined world, build a network of tunnels connecting every major city on Earth to every other. London to Tokyo, São Paulo to Mumbai, Cape Town to Montreal. Short chords and long chords, shallow cuts and deep ones, diagonals in every direction through the interior of the planet. And every single one of those tunnels, every person sliding into every one of them at the same moment would arrive at their destination at the same time. 42 minutes. There would be no short routes and long routes, no express lines and local lines, no advantage to being close or disadvantage to being far. The geometry of the Earth, combined with the mathematics of simple harmonic motion, levels everything into one universal transit time. In principle, in the pure, frictionless, uniform density ideal, it is the ultimate egalitarian transit system. A person sliding into a tunnel from anywhere on the surface, bound for anywhere else on the surface, and requiring only the same 42 minutes that everyone else requires, arriving with zero velocity, with no energy spent by any engine, no fuel burned, no power consumed. Gravity does every bit of the work, and gravity gives everyone the same schedule. Paul Cooper's paper noted this as a transit concept with an appealing logic to it. Because the tunnel requires no energy input, the gravitational force is the engine, and the engine runs for free. For a system of any scale, connecting any number of cities, the energy cost is the same, which is to say, nothing. The ultimate free transit. This is what the physics suggests in the ideal. The same beautiful, unsettling equality written into every chord. But there is something else the mathematics says about what happens after you arrive. You reach the other end. You have fallen for 42 minutes. You have gone from your starting point through the dark interior of the imagined Earth, and you arrive at the surface on the other side with exactly zero velocity, not slowing gently to a stop, not decelerating over a comfortable distance. You arrive with exactly zero speed at exactly the moment you reach the surface. The tunnel's mouth is there, and you are there, and you have nothing left. You are at rest. And then you begin to fall back. Because there is no friction in this imagined tunnel, there is nothing to hold you at the surface. The opening is just a hole, and you are at one end of it with zero velocity, and the Earth's gravity is still pulling you toward the center, and so you fall again. You fall back the way you came. You descend again through the 42 minutes, through the same curving deceleration that was acceleration played in reverse, through the midpoint again at the same 28,000 kilometers per hour, rising now rather than falling in the physical sense, but still following the same mathematical trajectory, and you emerge at your original starting point with zero velocity again after another 42 minutes. And then you fall again. Without friction, without any source of energy loss, this repeats. It repeats forever. You would oscillate between the two openings in an endless, perfect, self-sustaining rhythm. Down for 42 minutes, up for 42 minutes, down for 42 minutes, up for 42 minutes. Each trip identical to the last, each midpoint passage at the same speed, each arrival at each surface with the same zero velocity, the same stillness, the same hanging moment before the fall begins again. An eternal pendulum between two skies, the energy put in at the beginning, the energy of your position high up on the surface at the entrance to the tunnel, cycles perfectly between potential energy and kinetic energy and back again, endlessly. At the surface, you have maximum potential energy and zero kinetic energy. At the center, you have zero gravitational potential energy in the relevant sense and maximum kinetic energy. The total never changes. Nothing is lost. Nothing leaks away. The physics in this frictionless ideal allows the journey to continue for as long as the universe allows it, which is to say, for as long as you care to imagine. There is something almost meditative in the image of it held gently in the mind. The traveler, weightless in the dark interior, oscillating between one opening of sky and another, reaching the surface, pausing for a breathless instant, and falling again. Never tired in the physics. The physics does not tire. The numbers do not diminish. The amplitude of the oscillation does not shrink. An eternal pendulum between two holes in the sky. And here is where the mathematics opens one more unexpected door, the kind of connection that physicists love to find hidden inside already surprising results. The full round trip, down to the far side and back again to the start, takes approximately 84 minutes, 84 minutes and 24 seconds in the usual rounding. The period of the oscillation, the time to complete one full cycle of the pendulum, is about 84 minutes. Now hold that number alongside something else. A satellite orbiting the Earth in a very low orbit, flying just above the surface, where the atmosphere has been conveniently wished away in this thought experiment, following a circular path with a radius equal to Earth's own radius. A satellite in that orbit would take approximately 84 minutes to complete one full revolution. 84 minutes. The same number. This is not a coincidence in the way that the 42 and the Hitchhiker's Guide are a coincidence, which we will come to in a moment. This is a deeper structural equivalence, a piece of the mathematics that runs all the way through. The satellite skimming the surface and the traveler falling through the chord are governed by the same constant, the same relationship between Earth's mass and Earth's radius, the same fundamental number that characterizes how strongly this planet holds things near its surface. For the surface skimming satellite, the gravitational force provides exactly the centripetal acceleration needed to keep it in its circular path, and that calculation yields an orbital period of about 84 minutes. For the through-Earth traveler, the Shell theorem and the linear restoring force yield a simple harmonic period of about 84 minutes. The mathematics is different. One is circular orbital motion, the other is linear oscillation. But they arrive at the same number because they are both, at the deepest level, asking the same question about the same planet. How strongly does the Earth's gravity hold things at its surface? And the answer, encoded in different geometric forms in the two problems, is strongly enough to make 84 minutes the characteristic time. The faller and the orbiting satellite share one number. They are two different expressions of the same planetary constant, one falling through and one flying around, both taking 84 minutes to complete a cycle. There is a way in which they are the same journey, viewed from different directions. The satellite curves continuously around the outside of the Earth, following the exact path that a frictionless fall through a hollow Earth would trace if you bent it into a circle. The tunnel faller cuts through the interior, but the timekeeping is identical. The Earth is the same Earth for both of them, holding them both in the same gravitational relationship, and the relationship has the same period no matter which path you follow through it. 84 minutes for the orbit, 84 minutes for the round trip, 42 minutes for the one-way fall. The numbers agree because the universe, at least in the Newtonian mechanics that governs this regime, is built with a consistency that keeps surfacing in unexpected places. And then there is the matter of what air does to the journey. In everything we have described, the tunnel is assumed to be in vacuum, frictionless, empty of everything except the traveler and gravity. This is, for the thought experiment, a reasonable assumption. Evacuating a tunnel is a solvable engineering problem, at least in principle, in a way that the other problems we will reach shortly are not. But consider what happens if the tunnel is not evacuated. If it is simply a hole in the Earth, open at both ends, filled with air the way any open tunnel would be. The fall would begin the same way. You would step in, let go, and gravity would start pulling you downward. You would accelerate, but you would immediately be pushing air out of the way, and air resists. Air pushes back. At low speeds, the resistance is mild, easy to ignore, but as you fall faster and faster, approaching the speeds we have been imagining, the drag force grows rapidly. Every meter per second you gain, the air fights back a little harder. You would not reach 28,000 kilometers per hour at the center. You would not come close. The air would slow you long before that. But even setting aside the question of terminal velocity, even imagining a much lower drag scenario or a slightly viscous medium rather than open air, the fundamental effect of any friction on the oscillation is the same. It damps the motion. Each oscillation loses a little energy to the friction. Each time you pass through the center, you are moving slightly slower than the last time. Each time you reach the far surface, you do not quite make it to the opening. You turn around a little bit short, a little bit before the mouth of the tunnel because you ran out of kinetic energy slightly before you got there. And on the next oscillation, you turn around a little sooner than that, and the next time, sooner still. The amplitude of the oscillation shrinks, slowly at first if the friction is gentle, but relentlessly. The pendulum is losing energy with every swing, and it has nowhere to get it back from. The oscillation narrows and narrows, each extremity a little closer to the center than the last, until eventually the traveler is making only small excursions in either direction around the midpoint, and then smaller ones still, and then barely moving at all, and then finally at rest. At rest at the center, floating there, weightless. Not at zero gravity in the Shell theorem sense of no forces acting. The gravity is still there, still pulling from all directions, but balanced so perfectly that no net force pushes in any direction. At the very center, the gravitational pull from every direction cancels every other pull, and the net force is zero. You float, surrounded by the entire mass of the planet, all of it wrapped around you in every direction, and all of it perfectly balanced. This is where friction settles you. Not at the surface you were aiming for, not at any exit, not out the other side, at the center, floating weightless in the dark, in the exact middle of everything, with the entire Earth wrapped around you and nothing pulling you anywhere at all. It is, in a quiet way, one of the stranger fates the thought experiment can produce. The frictionless traveler oscillates forever, endlessly moving between two surfaces, never resting. The traveler with friction settles eventually to stillness, to the precise center, to weightlessness and rest. The physics of friction is, in this particular imagined scenario, the physics of coming to peace. And now, before we turn to the real Earth and what it is actually like in those depths, there is a small aside, the kind of gentle digression that can be offered late in a long journey when the major ideas are already in place and the mind is comfortable with where it has arrived. The number 42. Physicists who talk about the gravity tunnel in papers and lectures and conversations in the margins of more serious things often find themselves pausing at this number. 42 minutes one way to fall through the Earth. 42. In 1979, a British author named Douglas Adams published a novel called The Hitchhiker's Guide to the Galaxy, in which an enormous and ancient computer, after 7.5 million years of computation, announces the answer to life, the universe, and everything. The answer, famously and anticlimactically, is 42. The novel explains that this is true but unhelpful because nobody knows what the question is. The joke has lodged itself permanently into popular science culture. Anytime a calculation or measurement produces 42, someone in the room will note it. The gravity tunnel produces 42. This is a coincidence. Let us be clear about that. It is a coincidence in the precise sense. The physics did not arrange itself to please Douglas Adams, and Adams did not calculate gravity tunnel transit times before choosing his number. The 42 in The Hitchhiker's Guide was chosen for comic purposes, not physical ones. The 42 in the gravity tunnel is a consequence of Earth's specific radius and mass, and the constant of gravitation, and it would not be 42 if the Earth was slightly different in any of those parameters. On a larger planet with different properties, the transit time might be 67 minutes or 31 minutes or some other number entirely without a literary shadow. But 42 it happens to be for this Earth in this simplification, and physicists who are human note the coincidence with something between amusement and a faint, unearned satisfaction, the feeling of having found a joke written into the fabric of the planet. They are aware that it is not significant, They note it anyway, and then they return to the mathematics. It is the kind of small coincidence that the universe occasionally produces, the kind that means nothing and feels like something. A number shared between a comic novel about the absurdity of existence and a physics problem about falling through the earth. The problem and the novel have nothing to do with each other. The number sits between them, in the dark, glancing from one to the other. You can decide what to make of it. Most physicists suggest you make nothing of it and are probably right. And with that small, gentle aside folded in, the journey through the idealized tunnel is, in a sense, complete. We have the canonical 42 minutes for the through-center fall. We have the any-chord theorem and its strange equality across all distances. We have the eternal oscillation of the frictionless traveler, the endless pendulum between two openings of sky. We have the zero gravity at the dead center and the maximum speed at the same point. We have the 84-minute round trip that matches the orbit time of a satellite skimming just above the surface. We have the way air, or any friction at all, gradually steals the motion and deposits the traveler, weightless and motionless, at the exact middle of everything. This is the complete picture of the journey in the frictionless, uniform density, idealized world where the thought experiment lives. But the thought experiment has always been a lantern, not a map. A lantern shows you something real. The shell theorem is real. Simple harmonic motion is real. The any-chord result is real, a genuine theorem derived from genuine mathematics, not a simplification or an approximation. The zero gravity at the center is real in the sense that it follows inevitably from real physics applied to a spherically symmetric mass distribution. The 84-minute equivalence is real, a true structural connection between orbital and oscillatory motion that physicists care about because it reveals something true about the relationship between gravity and geometry. All of that is real. But the map it is trying to describe is not the Earth. The Earth does not have uniform density. The Earth has a structure, a layered, dramatically varied interior. And that structure changes everything about what would actually happen if you tried, which you could not, to fall through it. Before we walk into what the real Earth is actually like in those depths, there is one more number that the real Earth produces, the corrected number, the number that comes from measuring the actual density of the actual planet rather than assuming it away into simplicity. The uniform density model gives 42 minutes. The real Earth, with its dense iron-nickel core and its varying mantle and its thin crust, gives a different answer, a shorter answer. And to understand why it is shorter and what the people who calculated it had to do to get it, and what they were listening to when they built the model that makes the correction possible, is itself a small journey. The model has a name. It is called the Preliminary Reference Earth Model, PREM for short, and it was built from decades of seismological data, from the careful measurement of how earthquake waves travel through the interior of the planet, bending and refracting and bouncing as they pass through layers of different density and composition. The Earth's interior is, from the outside, invisible. No light penetrates it. No probe has ever reached more than a small fraction of the way toward the center. But earthquake waves pass through the whole thing, and they carry information encoded in the timing and arrival angles of their wavefronts about every layer they have crossed. Seismologists have spent the better part of a century decoding that information. Listening to the Earth's own vibrations, the low, slow waves that ripple through the planet after a large earthquake, like the ringing of a struck bell, measuring the speed of those waves at different depths, inferring from those speeds the density and elasticity of the material the waves were passing through, layer by layer, depth by depth, building up a picture of the planet's interior from the sound of its own catastrophes. The Preliminary Reference Earth Model is the result of that listening. A table of densities, pressures, wave speeds at every depth from the surface to the center. Not a measurement of any single spot, but an average, a reference model representing what a typical cross-section of the Earth looks like, the best available summary of the interior's structure. And when you use the PREM's actual density profile to redo the gravity tunnel calculation, when you replace the convenient fiction of uniform density with the real, measured variation in density that the seismological record has built up over decades, the 42 minutes does not survive. In 2015, a physicist named Alexander Klotz published a paper in the American Journal of Physics recalculating the gravity tunnel transit time using the PREM density profile rather than the uniform density assumption. The paper is careful and readable, the kind of physics paper that takes pleasure in making its method clear. And the result Klotz obtained was approximately 38 minutes. Not 42, 38. The famous number, the canonical number, the number that has attached itself to this thought experiment in textbooks and popular articles and physics conversations for decades, is technically wrong. Not dramatically wrong, 38 is in the same neighborhood as 42, but wrong in a way that the real Earth insists on if you ask carefully enough. The reason the real Earth gives a shorter time is straightforward once you understand what the PREM says about the planet's interior. The Earth's core is much denser than the surrounding mantle and much denser than the outer layers. The iron-nickel core concentrates a large fraction of the Earth's total mass in a small fraction of the Earth's total volume. The mass is not spread uniformly through the sphere. It is concentrated toward the center. And when more mass is concentrated toward the center, the gravitational pull at intermediate depths is stronger than the uniform model predicts. The shell theorem still applies. The mass outside your current radius still cancels out. But the mass inside your current radius is greater because a larger fraction of the total mass is crammed into the inner part of the sphere. So gravity, during the first part of the fall, is stronger than the uniform model suggests. The gravitational acceleration pulls harder, the traveler accelerates faster, the journey takes less time. 38 minutes, not 42. The correction is modest, 4 minutes, about 10%. But it is real, and it comes from real physics, from real measurements of a real planet, and it matters because it shows what the thought experiment cannot show by itself. The thought experiment is a clean piece of mathematics built on a simplification. The PREM is a hard-won portrait of what the planet is actually like, and the portrait says the planet's interior is not uniform. The planet's interior is a structure, a layered and violent and ancient structure, and the deeper you go, the more that structure diverges from anything the clean mathematics had imagined. 38 minutes, if the density profile is real. But even 38 minutes is a number that belongs only to the thought experiment, because the thought experiment has, all along, been quietly assuming that you can drill the tunnel, that you can bore a hole through the Earth, maintain it in some form that a traveler can pass through, evacuate it, and send someone through it without destroying them. And it is at this point that the real Earth steps forward and closes the door. Not gently. The real Earth does not discourage the gravity tunnel the way a difficult engineering problem discourages a project, the way cost or complexity or material availability might make something very hard, but not impossible. The real Earth discourages the gravity tunnel the way the interior of a star discourages a visit. With temperatures and pressures and physical conditions so far beyond anything human material or human biology can withstand, that the word impossible here is not hyperbole. It is description. Let us start with temperature, because temperature is the most picturable of the barriers. The inner core of the Earth, the solid iron-nickel sphere at the very center, the place the traveler in our thought experiment would pass straight through, is estimated to have a temperature of approximately 5,200 degrees Celsius. Some estimates place it higher, at 5,400 or approaching 6,000. The uncertainty exists because we have never been there, and the inference from seismic data and high-pressure laboratory experiments leaves a range, but the number around which the estimates cluster is 5,200 degrees Celsius. The surface of the Sun is approximately 5,500 degrees Celsius. Pause there and let the numbers sit next to each other. The center of the Earth is at roughly the same temperature as the surface of the Sun. Not the core of the Sun, which is far hotter, measured in millions of degrees, the surface of the Sun, the visible part of the Sun, the part that, from a safe distance of 150 million kilometers, delivers enough heat and light to power all life on Earth and drive all the weather on the planet and burn exposed skin in a few minutes. That temperature. At the center of the Earth. No material that human engineers have ever produced or conceived of producing survives 5,200 degrees Celsius in structural form. Steel melts at around 1,400 to 1,500 degrees Celsius. Tungsten, the most refractory pure metal available, melts at 30,422 degrees Celsius, which sounds high until you note that it is still less than 60% of the inner core's temperature. The most heat-resistant ceramics and composites humans have developed, the materials used in rocket nozzles and atmospheric re-entry vehicles, operate at sustained temperatures measured in the low thousands at most. At 5,200 degrees Celsius, the tunnel walls would not hold. The tunnel would not exist. The concept of a maintained void in the material, an open channel through which something might pass, dissolves at those temperatures into something that cannot be kept open because the surrounding material flows and collapses and fills any gap at those temperatures driven by the immense pressure on every side. Which brings us to the pressure. The pressure at the center of the Earth is approximately 360 gigapascals. A gigapascal is 1 billion pascals. A pascal is the pressure of 1 Newton per square meter. Atmospheric pressure at sea level is roughly 100,000 pascals, or about 1/10 of a megapascal. 360 gigapascals is therefore approximately 3.5 million times atmospheric pressure, 3.5 million atmospheres. There is not a practical way to make the number feel physically intuitive, because nothing in ordinary experience produces pressure remotely approaching it. The deepest point in the ocean, the Challenger, deep in the Mariana Trench, has a water pressure of about 1,080 times atmospheric pressure, immense, capable of crushing unprotected submarines, hostile to unprotected biology in every way. The pressure at the center of the Earth is more than 3,000 times the pressure at the bottom of the deepest ocean trench. Diamond, the hardest natural material on Earth, forms under pressures of around 5 to 6 gigapascals. It is stable at those pressures, at 360 gigapascals, 60 times the pressure that creates diamonds. Iron does not behave in the way iron normally behaves. The iron-nickel alloy at the Earth's center exists in a phase that has to be studied in specialized laboratory experiments using tiny samples compressed between diamond anvils, the most extreme high-pressure apparatus available to geophysicists. And even those experiments struggle to reach the pressures at the center of the Earth. The planet's interior is, in terms of pressure, one of the most extreme material environments we know of outside the interiors of much larger celestial bodies. At 360 gigapascals, nothing maintains an open channel, nothing keeps a hole open. The surrounding material is not rock in any sense that the word rock conveys in daily experience. It is rock under a compression so extreme that it flows over geological time almost like a very slow fluid. Under that pressure, a drilled tunnel would not stay open for long enough to matter. The material would flow back in, the passage would close. But even temperature and pressure are not the full account of what blocks the gravity tunnel, because they describe the barriers at the very center, at the innermost layer of the Earth. The traveler would have to cross something before ever reaching the inner core. Between the mantle and the inner core, there is a layer that the thought experiment has not yet paused on. The outer core. The outer core of the Earth extends from approximately 2,890 kilometers below the surface, down to approximately 5,150 kilometers below the surface. It is a layer roughly 2,260 kilometers thick, thicker than the continental United States is wide. And it is not solid. The outer core is liquid. It is a vast, churning, convecting ocean of liquid iron and nickel, a sea of molten metal thousands of kilometers deep, through which the thought experiment's tunnel would have to pass before reaching the solid inner core at the center, and then again on the way back out. This is not a thin layer. This is not a technical complication. This is an ocean of liquid metal larger in volume than the entire solid inner core many times over, and it is not quiescent. The liquid outer core is in constant slow motion, driven by the heat flowing outward from the inner core and by the rotation of the Earth. Those motions, the convection currents in the liquid iron-nickel sea, are what generate the Earth's magnetic field, the enormous planet-wide magnetic field that deflects the solar wind and makes compasses point north and allows life at the surface to exist without being bathed in lethal radiation. The magnetic field is not a separate structure sitting somewhere. It is the product of the flowing liquid metal of the outer core, the electrical currents induced by that flow, the dynamo at the heart of the planet. And through that dynamo, through that churning metallic sea, the gravity tunnel would have to be maintained. You cannot hold a hole open through a liquid. The concept of a maintained tunnel requires a medium that can be shaped and will hold its shape, at least for long enough for the purpose. The outer core is not that medium. It is a liquid, and liquids fill holes. If you somehow removed the material from a channel through the outer core, the surrounding liquid metal would flow back in under the enormous pressure at speeds determined by the viscosity of liquid iron at those temperatures and pressures. The answer is immediately. The outer core does not permit tunnels. It permits only the slow, vast, three-dimensional flow of iron in the dark at temperatures and pressures that make the conditions in any human-built machine or structure look like a mild afternoon, and it will not hold the shape of anything that tries to pass through it in a straight line. So we have three barriers, stacked concentrically, each one alone sufficient to close the question forever. There is the temperature. 5,200 degrees Celsius at the center, comparable to the surface of the sun, lethal to any material. There is the pressure. 360 gigapascals, 3.5 million atmospheres, sufficient to crush any tunnel and any traveler to nothing. And there is the outer core. 2,000 kilometers of liquid iron nickel, a sea of molten metal that cannot maintain the shape of any passage through it. Even granting, hypothetically, the existence of a material that could survive the temperature and the pressure, some imagined future alloy or ceramic beyond anything in current or foreseeable science, the outer core would still prevent the tunnel. You cannot bore a channel through a flowing liquid and expect it to stay. And even if you could somehow hold the outer core's liquid metal back, with some hypothetical force field or pressure management system that no physics we understand would permit, the inner core's temperature would still destroy the walls and the traveler. The barriers reinforce each other. They are not sequential obstacles that might be solved one at a time. They are the properties of the real Earth, the actual Earth, the one beneath your feet as you read this or listen to it, and they are not going to change. The gravity tunnel is not merely beyond our current engineering capability. The way that a Mars colony or a kilometer-long suspension bridge might be described as beyond current engineering capability, but plausible in principle with enough advancement. It is beyond any plausible engineering capability because it requires maintaining a physical structure through conditions that are fundamentally incompatible with the existence of structures. The materials that would be needed do not exist and cannot exist because at those temperatures and pressures, the properties of matter itself preclude the kind of rigid, structured form that a tunnel requires. And yet the thought experiment is real, the physics is real. The 42 minutes, or 38 minutes, if the Prem is consulted, are derived from real laws about real gravity acting on a real planet. The shell theorem is Newton's. The simple harmonic motion is as well established as any result in classical mechanics. The Anycord theorem is a genuine mathematical result. The thought experiment gives you something true about the universe, even though it describes something the universe will never allow you to do. Human beings have drilled into the earth. The effort to penetrate even a small distance below the surface is instructive, in the way that careful failure is always instructive. The deepest hole ever drilled by human beings is in the Kola Peninsula in Russia, near the northwestern extremity of the country above the Arctic Circle. The drilling project began in 1970 and continued for roughly 20 years. The goal was scientific. The Soviet Union wanted to probe the crust of the Earth in a deep borehole, sampling the rock and measuring the properties of the crust at genuine depth, testing the models that seismologists had built from earthquake data against actual material brought up from depth. After approximately 20 years of drilling, using the most advanced drilling technology available at the time, continuously rotating the drill string, managing the temperature and pressure at the drill tip, the Kola Super Deep Borehole reached a depth of 12,262 meters, 12.26 kilometers. The Earth's radius is approximately 6,371 kilometers. The center is that far away from the surface. The Kola borehole went 12 kilometers, that is roughly 0.2% of the way to the center, 1/5 of 1%. If the journey to the center were represented as a kilometer-long road, the Kola borehole would have taken you about 2 meters. The project did not stop because of a lack of effort or funding or political will, though all of those eventually played a role. It stopped in significant part because the temperatures encountered at depth were far higher than the models had predicted. At 12 kilometers down, the temperature was approximately 180 degrees Celsius. That is roughly twice what had been expected. The rock at that depth, under that temperature, was not behaving like the cold, rigid rock near the surface. It was becoming plastic, beginning to flow slowly in the way that materials flow when they are warm enough and the pressures are high enough. The drill tip was entering material that was fighting back, that was closing around it, that was no longer the hard, stable substrate that drilling technology is designed for. 180 degrees Celsius. At 12 kilometers, the inner core is 5,200 degrees Celsius at 6,371 kilometers. The scale of the gap between what has been accomplished and what the gravity tunnel requires is not a gap that additional engineering progress will close. It is not the gap between a boat that can go 20 knots and a boat needed to go 40 knots, a factor of 2 that faster engines and better hulls might address. It is the gap between a candle and the surface of the sun. The Kola borehole sits in the Earth's crust. It never left the crust. The mantle begins at roughly 30 to 50 kilometers depth beneath the continents, and the borehole stopped at 12. It never reached the mantle. It never came close to the mantle. The entire progression from crust to mantle to outer core to inner core, the layers that the gravity tunnel would have to traverse, begins where the borehole ended and extends more than 6,000 kilometers further down. Human beings have not reached the mantle. Human beings are very far from the mantle. Human beings have not begun. And yet, on a still evening, lying in the quiet of a dark room, with the sounds of the outside world settling into that particular evening, stillness that comes when things close and the world withdraws, it is possible to hold the thought experiment in the mind with a kind of calm appreciation for what it genuinely is. It is a window into real physics, a clean, elegant derivation that follows from Newton's laws and the geometry of a sphere and the mathematics of oscillation, and that produces results: the 42 minutes, the Anycord equality, the zero gravity at the center, the eternal oscillation, that are not obvious until the mathematics reveals them, and that remain genuinely surprising even after the derivation is understood. The thought experiment does not describe a journey you will take, but it describes a truth about the Earth you stand on. Beneath you, right now, the shell theorem is operating. The mass in the shells above the center is doing exactly what Newton described, cancelling out, exerting no net force on anything at the center. The outer core is churning, its liquid iron-nickel convecting in slow, enormous loops, generating the magnetic field that reaches all the way out to where you are and bends around you. The inner core is sitting at 5,200 degrees Celsius, solid despite the heat because the pressure will not let it melt, patient and incomprehensibly dense. All of that is there, right now, beneath you. You cannot fall through it, but it is there. And so we arrive in the quiet of this final passage at something the famous number does not quite tell you. 42 minutes. It is a beautiful number as these things go. Memorable, round, carrying that coincidental echo of a science fiction novel's cosmic joke. And for many years in popular accounts of the gravity train thought experiment, 42 minutes was where the story stopped. The headline, the punchline, the fact you might carry away from an article and mention once at a dinner before it faded back into the general haze of interesting things you once read. But there is a correction to make. A quiet, careful correction that does not diminish the wonder of the result, but sharpens it, the way a good lens sharpens a view that was already worth looking at. In 2015, a physicist named Alexander Klotz published a recalculation in the American Journal of Physics. His question was simple and precise. What happens to the fall time if, instead of imagining the Earth as a uniform sphere of constant density, the assumption that gives you the clean 42 minutes, you use what we actually know about the Earth's interior structure? Because the Earth is not uniform. Not remotely. The density of rock near the surface is somewhere around 2 to 3 grams per cubic centimeter, which is to say roughly 2 or 3 times the density of water. Solid, heavy, what you would expect of stone. But as you descend toward the core, the density climbs dramatically. The inner core of the Earth has a density of around 13 grams per cubic centimeter, several times denser than ordinary rock, denser than lead, closer in density to osmium than to anything you would find in a quarry or on a mountainside. The real Earth is not a uniform ball, it is a ball with an extraordinarily heavy heart, and that matters for the falling calculation in a specific, consequential way. When physicists want to work with a precise, agreed-upon picture of Earth's interior, a model that incorporates everything seismology has told us about the density and composition at every depth, they use what is called the Preliminary Reference Earth Model, PREM for short. This is not a single person's theory. It is a careful, internationally used scientific consensus picture of what the Earth's interior looks like, derived from decades of analyzing how seismic waves travel through the planet after earthquakes. Those waves speed up and slow down depending on what they pass through, and by studying their behavior from thousands of earthquakes recorded at thousands of stations, geophysicists have been able to construct a detailed and well-tested portrait of the interior. PREM tells you, layer by layer, what the density and composition and pressure and temperature are throughout the Earth. And Alexander Klotz took that model and ran the gravity train calculation with it, replacing the smooth, simplified uniform sphere with the actual lumpy, layered, dense-at-the-heart Earth it represents. The result was not 42 minutes, it was approximately 38 minutes. 38 minutes and some seconds for a single one-way passage through the center of the real Earth, from one surface to the antipodal point on the other side. 4 minutes faster, not a small correction. And the reason makes a kind of beautiful sense once you see it. In the uniform density model, gravity decreases smoothly and gently as you approach the center, because the shells above you are peeling away at a steady rate, and the mass remaining below you shrinks proportionally. But in the real Earth, the dense iron-nickel core means that there is far more mass concentrated in the deep interior than the uniform model allows for. More mass below you, even when you are deep, means stronger gravity, means stronger restoring force, means the oscillation happens faster, means you arrive sooner. The dense heart of the Earth does not just wait for you at the bottom, it accelerates you more aggressively on the way down. Think of it this way. Imagine a spring. In the uniform density model, the spring constant, the stiffness, is set by the average density of the whole sphere. But in the real Earth, the spring has a heavier, stiffer section in the middle. That heavier middle pulls harder when you are near it, and harder pulling means faster oscillation. A stiffer spring bounces faster. And so the real Earth's faller, swinging through the dense core, swings a little faster than the ideal model predicts. 42 minutes is the textbook answer. 38 minutes is closer to what would actually happen if the physics were otherwise identical and the engineering were somehow possible, which it is not. And this is where we must turn away from the mathematics gently, without hurry, and face the thing that the equations have been quietly setting aside all along. The wall, not a metaphor, a literal, physical, absolute wall of conditions so extreme that no material science currently imagined, no engineering concept currently conceived, no technology currently on any drawing board in any country could penetrate it. Let us descend through it in the mind, slowly, one layer at a time, the way you might lower a thermometer into something you suspect is much hotter than it looks. The crust first, the outermost shell of the Earth, the layer that roads are cut into and mountains are built from and oceans rest on. It varies in thickness from roughly 5 or 6 kilometers at the thinnest points under the ocean to perhaps 70 kilometers under the thickest parts of the continents. In absolute terms, the crust is the thinnest of skins. If the Earth were the size of a standard desk globe, the crust would be thinner than a sheet of paper pressed around it. Drilling through the crust should be, in principle, the feasible part. Rock is hard, but it is not impossible. Human beings drill through rock constantly, for mines and tunnels and wells and boreholes. The technology is mature, but then there is the Kola super-deep borehole. In the early 1970s in the Murmansk region of what was then the Soviet Union, a drilling project began with the specific ambition of going deeper into the Earth than anyone had ever gone. Not to extract anything, not to build anything, purely to learn what was down there, to bring back samples and data from depths that no instrument had ever reached. The drill went down for approximately 20 years. 20 years of continuous drilling through some of the most technically demanding conditions ever encountered in a borehole, with teams of engineers and scientists rotating through the project, refining techniques, solving problems as they arose, pushing the technology to its limits. After 20 years, the Kola super-deep borehole reached a depth of 12,262 meters, 12 kilometers, 262 meters. In a planet whose radius is 6,371 kilometers, the deepest hole human beings have ever drilled, the product of 20 years of serious, funded, deliberate scientific effort by a technologically sophisticated nation, reaches approximately 0.2% of the distance to the center, 1/5 of 1%. If the Earth's radius were the height of a 30-story building, the Kola borehole would have reached the top of the first step, and it stopped. Not because the will or the funding ran out, though those were factors. It stopped because the rock itself refused to cooperate. The temperatures at that depth, around 12 kilometers down, reached approximately 180 degrees Celsius. This was far higher than the models had predicted. The rock under that heat did not behave like cold rock. It became plastic, soft, almost like warm putty in geological terms. And plastic rock at high pressure tends to close back around a drill hole, squeezing it shut, making it nearly impossible to continue. The borehole had to be abandoned, 180 degrees Celsius, 12 kilometers down, and the center is 6,371 kilometers away. The numbers do not require much elaboration. Let us continue the descent in the mind past the point where the drill stopped, past the base of the crust, and into what lies beneath. Below the crust is the mantle. The mantle is enormous. It extends from the base of the crust all the way down to roughly 2,890 kilometers depth, making it by far the largest of the Earth's layers by volume. The mantle is not liquid in the way that water is liquid. At the time scales of human experience, it is solid enough that seismic waves, which can only travel through solid material as shear waves, pass through it without difficulty. But at geological timescales of millions of years, the mantle material flows. It convects in vast, impossibly slow currents, carrying heat from the depths toward the surface, and it is this slow convection that drives the movement of the tectonic plates and, in the fullness of deep time, reshapes the surface of the planet. The temperature through the mantle rises steadily as you descend, from a few hundred degrees Celsius near the top to somewhere around 4,000 degrees Celsius near the bottom. Pressure climbs too, from the modest levels of the upper crust to something like 140 gigapascals at the base of the mantle. A gigapascal is a unit of pressure. 1 gigapascal is roughly 10,000 times the atmospheric pressure you feel sitting in this room right now. 140 gigapascals is therefore roughly 1,400,000 times atmospheric pressure. The base of the mantle presses on everything below it with a weight that has no analogy in ordinary experience, and then, at approximately 2,890 kilometers below the surface, the mantle ends. Below it, the outer core. The outer core is a layer of liquid iron and nickel churning in slow, enormous convective currents, extending from roughly 2,890 kilometers down to about 5,150 kilometers depth. It is, in terms of the planet's structure, a vast ocean of molten metal. Not metaphorically, but literally. A sea of liquid iron nickel thousands of kilometers thick, sitting at temperatures of somewhere between 4,000 and 5,000 degrees Celsius, under pressures that would compress any familiar material into a state that has no common name. This liquid metal ocean is not quiet, it moves. The differential rotation of the inner core and the outer layers, combined with the Coriolis effect of the Earth's spin, drives the liquid iron nickel in complex, slowly evolving patterns of flow. And it is this flow that generates the Earth's magnetic field, the geodynamo, the invisible shield that extends far out into space and deflects the solar wind that would otherwise strip away the atmosphere over geological time. The outer core is not incidental. It is the engine of the magnetic field on which surface life depends. Any tunnel bored through the Earth from surface to surface would have to pass through this layer, both going in and coming out. You cannot bore a tunnel through liquid. There is no wall to bore into. The liquid outer core is not a material you can drill through and leave a hole in. A hole drilled into liquid closes immediately because liquid flows back. There is no engineering solution to this. No lining, no casing, no material currently known or theoretically predicted could hold open a tube through thousands of kilometers of liquid iron nickel at 5,000 degrees Celsius and 150 to 300 gigapascals of pressure. The outer core does not present an engineering challenge that waits for sufficiently advanced technology. It presents a categorical impossibility given everything we know about how matter behaves. But let us, in the mind, pass through it anyway, because the mind can go where materials cannot, through the liquid iron nickel still descending. The pressure continues to climb, temperature continues to climb, and then at approximately 5,150 kilometers below the surface, something changes. The outer core ends. The inner core begins. And the inner core is solid. This is one of the stranger facts in all of geophysics, and it deserves a moment of quiet attention. The inner core is hotter than the outer core. Temperatures there are estimated at around 5,200 degrees Celsius, comparable to and possibly exceeding the temperature at the surface of the Sun. The Sun's photosphere, the luminous surface you see when you look up on a clear day, and of course you should never look directly at it, is at approximately 5,500 degrees Celsius. The inner core of the Earth is in the same rough temperature neighborhood. By any ordinary expectation, the inner core should be molten. It should be the most thoroughly liquid part of the whole planet, the hottest, deepest, most extreme region. But it is solid. It is solid because of pressure. Under sufficient pressure, the melting point of iron rises. The iron-nickel alloy in the inner core sits at temperatures that would absolutely melt it under the pressures of the surface. But at the pressures of the inner core, pressures estimated at around 360 gigapascals, roughly 3.5 million times atmospheric pressure, the melting point of iron is higher. The pressure pushes the atoms together so tightly and with such force that even at 5,200 degrees Celsius, they cannot rearrange themselves into the disordered configuration of a liquid. They are held in something more like a crystalline structure by the crushing weight of the planet above them, 360 gigapascals, 3.5 million times the pressure of the air in this room. To translate that into something that approaches everyday experience, the pressure at the bottom of the deepest ocean trench is about 1,000 times atmospheric pressure. 1,000 atmospheres is enough to crush unprotected submarines and to require the most robust engineering to withstand in any piece of equipment. 3.5 million atmospheres is 3,500 times more than that. It is not a matter of making a stronger vessel. The pressure at the inner core would not merely crush a vessel, it would compress whatever material the vessel was made of into a different state of matter, because at those pressures, the electrons in the material's atoms begin to overlap and behave collectively, and the material itself becomes something that has no name in ordinary materials science. The inner core sits at the center, roughly 1,220 kilometers in radius, a sphere of solid iron nickel at incomprehensible pressure and sun surface temperatures. In the center of the planet you walk around on every day. So let us recapitulate the journey, layer by layer, the way you might trace a route on a map before setting out. Except this is a route no one will ever travel. From the surface down through the crust, the familiar rock, the cold stone, the world that drills and mines and wells have barely begun to touch. The deepest human drilling, 12 kilometers after 20 years of effort, only just scratches the lower reaches of the thickest continental crust. Then through the mantle, thousands of kilometers of rock that is solid on human timescales but flows on geological ones, growing hotter and more pressurized with every kilometer, reaching temperatures of several thousand degrees and pressures of over 100 gigapascals by the time it ends. Then, into the outer core, the liquid iron-nickel ocean, the geodynamo's engine, the layer that destroys the possibility of any physical tunnel by its nature alone, the churning metallic sea that extends for more than 2,000 kilometers and would close around any opening instantly and forever. Then, through into the inner core, the solid iron-nickel sphere, hotter than the sun's surface, under pressures that have no material analog, sitting at the exact center of everything, and then back out through the inner core on the far side, out through the outer core again, up through the mantle again, up through the crust on the other side of the planet, and out at the antipodal point. This is the journey the mathematics describes. The thought experiment traces it clearly and without apology. The numbers come out to approximately 38 minutes at realistic density, 42 at the simplified model, and the physics of it is clean and beautiful and real. The planet's interior is not clean, not beautiful in any conventional sense, and not survivable. These two things are both true simultaneously, and there is something worth sitting with in that. The physics of the thought experiment is genuine. The shell theorem is real. Simple harmonic motion is real. The equal transit time for any chord is a real, proven mathematical result. The zero gravity at the center is a direct consequence of Newton's laws applied to a spherical body, not a speculation or an extrapolation. These are not approximations or hand-waving. They are the actual behavior of gravity in a spherically symmetric body, and they would apply to the real Earth if the real Earth were traversable, which it is not. The blocking conditions are equally real. The 5,200 degrees Celsius of the inner core is not a projection or a model artifact. It is our best estimate of a measured, tested, seismologically constrained reality. The 360 gigapascals of pressure is derived from the density and mass distribution measured through decades of seismic analysis. The liquid outer core is not inferred from a single observation, but from the fundamental behavior of seismic shear waves, which cannot pass through liquid and are observed to be absent in the shadow of the outer core for every earthquake ever recorded. These are as well established as anything in planetary science. So the thought experiment describes a genuine truth about how gravity works, applied to a planet whose interior makes that truth forever theoretical. There is a particular kind of wonder in that. It is the wonder of something that is completely understood and completely unreachable at the same time. Most things that are unreachable are also mysterious, too far away, too small, too fast, too embedded in systems too complex to analyze. The gravity train is unreachable for almost the opposite reason. It is perfectly understood, geometrically and mechanically down to the decimal places of the fall time, and the expression for the oscillation period, and the exact speed at the midpoint, and the behavior at every depth. The mathematics is not approximate. It is exact for the idealized case and very precisely corrected for the real case by the preliminary reference Earth model and Alexander Klotz's recalculation. What blocks it is not mystery. What blocks it is matter. The sheer physical extremity of the planet's interior, which the mathematics can describe perfectly and which nothing we have or can reasonably imagine having could traverse. The thought experiment is a window with nothing beyond it but glass. You can see through it completely. You cannot step through it. And the view from the window is accurate. There is something almost restful about this, viewed from the right angle, in the right mood, at the right hour. Not the restfulness of defeat or of giving up, but the restfulness of completeness. The question what would happen, has a full answer. It has been given. The 42 minutes, or 38, with real density. The zero gravity at the center. The maximum speed of 7.9 kilometers per second at the midpoint, 28,000 kilometers per hour, faster than any rocket humanity has launched. The eternal oscillation without friction, the gentle damping to a weightless rest at the core with friction, the any chord equality, the same transit time for any straight tunnel anywhere on the planet, the eerie coincidence with the orbital period of a satellite grazing the surface. All of it known, all of it derivable, checkable, verified, and the planet's interior setting an absolute physical boundary around it. The satisfaction, if you allow yourself to feel it, is the satisfaction of a question that has been genuinely answered, not gesturally, not approximately, but fully. You know what would happen. You know why it cannot happen. Both halves of the answer are real. Paul Cooper, writing in the American Journal of Physics in 1966, described the gravity train as a thought experiment with real engineering implications. The theoretical possibility of a transit system that required no energy input because gravity did all the work, moving passengers between any two surface points in the same 42 minutes regardless of distance. The elegance of that idea was part of what made his paper worth writing. In a world of perfect materials and impossible engineering, every city would be 42 minutes from every other city along a straight, frictionless tunnel, and the energy cost of the journey would be exactly zero. That is a beautiful idea. It belongs to the same family as perpetual motion machines and perfectly efficient engines. Not achievable, but illuminating precisely because of what blocks achievement and what the unachievable ideal reveals about the achievable reality. Robert Hooke, writing to Isaac Newton in 1692, was already turning the problem over in the way that people in that era turned physical problems over. With genuine curiosity about what would happen, with the intuition that the mathematics of motion and the mathematics of gravity ought to have something interesting to say to each other about a hole through the earth. He was right. Newton's own Principia Mathematica, published in 1687, contained the shell theorem that would become the foundational result, that the shells above you cancel out, that only the mass below you counts, even if Newton did not apply it explicitly to the through-earth fall in the way later mathematicians would. The problem has been around for as long as people have understood that the Earth has an interior and that gravity is a force with mathematical structure. And it still produces the same clean answers: 42 minutes or 38, zero gravity at the center, eternal oscillation, equal time for any chord. The Earth beneath you, right now, is doing all of this, whether you think about it or not. The shell theorem is operating in the planet you are lying on. At the geometric center of the Earth, the gravitational forces from all directions cancel to zero, not because there is no mass, but because the mass is arranged symmetrically around that point, and Newton's laws say the symmetry resolves to nothing. The outer core is turning, its liquid iron-nickel in slow convective motion, maintaining the magnetic field that wraps around the planet and bends away from you the charged particles of the solar wind that would otherwise reach the surface. The inner core is sitting at 5,200 degrees Celsius, under 360 gigapascals of pressure. Solid, because it has no choice. Patient, because patience is not something the inner core needs to practice. It has been in that state for billions of years and will remain in it for billions more. None of that changes because it is night and quiet and you are at rest. The planet is doing what the planet does, as it has always done, in the deep darkness below everything we have built or thought or measured. And in the thought experiment, the imagined traveler is still falling. Frictionless, weightless in free fall from the first instant, accelerating through the dark toward a midpoint of perfect weightlessness and maximum speed, then decelerating smoothly, arriving at the far surface with exactly zero velocity, pausing for less than an instant, and then falling back, always falling back. An eternal pendulum between 2 points of light at either end of a tunnel that does not exist and cannot exist, swinging back and forth through the center of a planet whose heart would destroy any material object in an instant, oscillating in the clean mathematics of simple harmonic motion forever, conserving its energy perfectly because there is nothing to take the energy away. It is, in its way, one of the more peaceful images that physics has to offer. A frictionless fall through the center of everything, taking 38 minutes by the real measure, arriving in silence, returning in silence, a perfect pendulum in a perfect tunnel, in a planet that is, in its actual interior, anything but perfect. Anything but still, anything but cool, anything but hospitable to the geometry the equations describe. And yet the geometry is real. The equations are right. The thought experiment is not a fantasy about a world that works differently from ours. It is a precise description of how our world would work if only the interior of our world were not what it is. There is something in that worth carrying to sleep with you. If you are somewhere in the world tonight, lying quietly, the question of where has its own particular weight. This kind of careful, slow journey through ideas, through the physics of falling, through the geometry of spheres, through the exact and counterintuitive results that Newton's laws produce when applied to the planet we live on, this kind of journey works best in the dark, in the quiet, when the day is done and the mind is willing to be led somewhere slowly without needing to arrive urgently. If you feel moved to share where you are in the world tonight, the comments are there. I read them. There is something warm about knowing that someone in one place and someone in another and someone somewhere further still are all, on the same night, holding the same thought in mind. The thought of falling through a planet, slowly, in the mathematical dark, arriving weightless at the center of everything. The tunnels are quiet now, in the imagining of them. The traveler is at rest at the far end, momentarily still, before the fall begins again. The geometry holds. The physics is patient. The earth is exactly what it has always been. Beautiful in its mathematics, unyielding in its matter, ancient in its fire. History will still be here in the morning. For now, rest.